And good day, Algebra. We are continuing, going back to talking about that third and final method to solve a system of equations. It is elimination. This is the power objective of the three. On the test, you can use whatever method you want to. If you want to solve all of them by substitution, be my guest. If you want to draw your own chorded planes and solve all of them by graphing, that's fine too. If you decide, you know what, this oxenoid thing works out for me pretty well, you can solve all of them with elimination as well, okay? Just kind of depends on how your brain works, how you want to think about it. But we did this one together on Friday, and who can kind of remind me, what is the goal of elimination? What are we trying to accomplish here? Yeah.
You're trying to eliminate one of the variables.
Yeah, and how do we do that? What mathematically allows us to eliminate one of the variables? Right, you essentially want to get your coefficients to x or the coefficients to y to be the same. And the process to do that is to find the least common multiple and work to get to that number. Now, did we define elimination on Friday? No, okay. So elimination is to eliminate a variable by getting like coefficients for x or y. And my trademarked phrase for this is ox or oy, because if you eliminate the x variable, you get 0 x's, ox. If you eliminate the y, you get 0 y or oy. Okay? Give myself a little shout out there. And so what we did was we decided to eliminate x, which we looked at our coefficients for x currently, those 2 and 7, and we decided to make them both into a 14, which is the least common multiple of 2 and 7. So how do we do that? How do we turn that 2x into a 14x? Tristan? Multiplied everything in the equation by 7. Okay? As long as you keep that same scale, it's kind of like a scale factor, right? If you have a fraction, to write an equivalent fraction, what do? You multiply the numerator and the denominator by the same thing. Okay? To write an equivalent equation, as long as you multiply everything by the same thing, the value of the equation, the value of the variables, doesn't change. Right? So we're multiplying everything by 7. And that gave us 14x plus 35y equals 7. What do we do with the bottom equation? And there are a couple of you gone Friday, so this is your first time seeing this. Make sure you're taking really good notes here. Kaylin?
Multiply everything by 2.
Yeah, multiply everything by 2, right? Because that's what will give us that 14x. So the question that kept coming up Friday was, where do you get the 7 and the 2? You really kind of, you need them to get the 14. The 14x is your goal. What numbers do you need to make that happen? Turns out to be 7 and 2. But you multiply the negative 8 by 2 as well. That gives you negative 16y. And then 29 times 2 is a positive 58. Cool. Now what? Nick, how do we now eliminate that x variable? We've got the 14x's. What's that? Okay? You subtract them, right? Because if you have 14x's and you subtract 14x's, how many x's do you have? You've got your ox, right? 0x. You've eliminated the x variable from the equation because 0x is the same as having nothing, right? Now, where this can kind of turn into a details nightmare for those of you that don't like to show your work or like to skip steps, this is what's going to come back to haunt you. This subtraction sign, you've got to go back to that every single time. This 16y is negative, right? So this calculation becomes 35 minus negative 16, which is actually 35 plus 16. So if you're looking at your notes and thinking, how did I get a 51y from 35 minus 16? That's because you didn't take 35 minus 16. It's 35 minus negative 16. So you got to watch out for that, okay? And then 7 minus 58 is a negative 51. And because 0x is the same as just 0, we have 51y equals negative 51. Now, particularly for those who weren't here Friday, I'm just going to assume that I lost you somewhere along the way because this is a lot of steps and it's fairly complicated. But what questions do you have? Or if you were here Friday also, what questions do you have? Okay. How do we get y by itself now? We've left ourselves with a much easier equation to solve than what we had at the start.
Divide 51.
Divide both sides by 51, and we get y equals negative 1. Are we done? No. What do we do now? How do we solve for x? Cole? Now that we've got y, okay? Eli, now that we've got y, how do we solve for x? Yep. Does it matter which equation we plug y into to solve for x? Could we go to our original top one? Could we go to our original bottom one? Maybe your lucky number is 14. Could we go to our new top one? Yes, we can. Can we go to our new bottom one? Yes, we can. Any of those four can be used to solve for y because they're all equivalent equations part of the system. That's the beauty of multiplying everything by 7, everything by 2, is that these equations are now equivalent to what we originally had. Okay? But we'll go to the top one. 2x plus 5 times negative 1 equals 1, or 2x minus 5, because 5 times negative 1 is a negative 5 equals 1. You could probably do this in your head mentally. Add 5, divide by 2, x ends up being 3. So the solution to the system, x is 3 and y is negative 1. Isn't this fun?
No. Yes.
I don't want to be.
Yeah.
I mean, I've had a lot more fun.
I just don't want to go
Yeah. I mean, you know, as far as other things we've done in class this year, this is some pretty good stuff. Before I delete it and move on to the practice at the bottom, any other questions that folks have?
When will this be in our everyday lives?
We just did a whole bunch of word problems in PO41 part 2 that kind of related to it. We'll have even more in PO42 part 2 that you can look at for answer that question. Cool.
Football question. What team is Derek Carr, do you think, going to?
Derek Carr, he will retire and become a broadcaster for ESPN.
I think he's going to the Jets.
That's my call. All right. Looking down at the bottom here. Oh, by the way, Oxenoy has been copyrighted, so you are only allowed to use it with permission.
No.
Can I use oxynoid?
I don't see the
Yes, you may.
one.
6x plus 5y equals 22. 6x plus 4y equals 20. Do we need to do any multiplication here? No. Why not? Because 6x and 6x already have the same coefficient, right? So how do we turn a positive 6x and a positive 6x into 0x? Subtraction. So we're going to subtract the equations. 6x minus 6x is 0x. There's our ox. 5y minus 4y is just 1y. And if you want to write 1y or just y, either one's fine. And then 22 minus 20 equals 2. Well, that was
Simple.
That was pretty fun. That was pretty good, right? That's the basic idea behind this. Okay? It looks intimidating sometimes at the start because you got all these numbers, you got negatives, you got positives, but really once you get down to that coefficient being the same, this is all that's happening. Right? You're combining the equations to eliminate one of the variables, and in this case, we don't even have to do anything else. We don't have to divide by anything because y equals 2. Right? How do you want to solve for x? Millie, which equation would you like to plug 2 into? The first one or the second one? First one. Very well. So to solve for x now, we got 6x plus 5 times 2, because y equals 2, and that equals 22.
Doesn't 5 minus 1, doesn't 5 minus 4 equal 1?
Yes, and having y by itself or writing 1y, those two things are the same.
Oh.
Yep, those two things are the same. So 6x plus 10 equals 22. Subtract 10 from both sides. 6x equals 12. Divide by 6. Well, that's fun. X equals 2, 2.
X equals 2. Did you do the last one?
Yes, we will get to all of them. Folks, what's the issue?
My pencil keeps launching it. And my pen keeps launching it.
Maybe it's time for a new pen.
I don't have another pen.
Katie.
Are you happy with us when you made that question?
Yes. These all of these are kind of yes. Yes. We'll go with that. Yes. Simple answer. Let's look at the next one. Negative 5x plus 12y equals 90, and 7x plus 3y equals negative 27. Let's just start with what are our options here? If you wanted to get x by itself, what would you go to? Or sorry, if you wanted to eliminate x, meaning get the coefficients to be the same for your x terms, what would you have to go to here? What would you most likely? 35, right? Because that's the least common multiple of 5 and 7. If you go to positive 35, negative 35, that part doesn't make a difference, okay? But we have to multiply both equations, right? Top one by 7, bottom one by 5. Yeah, that can get a little bit messy. If you want to get the, if you want to go for OI, if you want to eliminate the y variable, what would you go to there? 12, right? Because 3 goes into 12 already. So in this case, you only have to multiply one equation. And because mathematicians are just inherently lazy, we're going to go that route. What do we have to multiply our bottom equation by? Well, by 4. Excellent. So in this case, our top equation doesn't change. Negative 5x plus 12y equals 90. But now our bottom equation, we multiply everything by 4. 7x times 4 is 28x. And the reason why we multiply by 4 is for this right here, because now our y term also has a coefficient of 12. Therefore, we can eliminate it. Okay? And then negative 27 times 4, what is that? Negative 108. Okay? Are we going to be adding or subtracting our equations here? What makes a positive 12 and a positive 12 equal to 0? Subtraction. Okay? So, again, go back to that sign. Negative 5x minus 28x is how many x's? Negative 33. 12y minus 12y. Here's our OI. And 90 minus negative 108. Positive, negative,
198.
positive 198. Okay? Don't forget to go back to that subtraction sign. That's why I put it in red. All right? Hopefully it stands out. Okay? So since 0y is the same thing as just 0, we really have a one-step equation to solve here. Negative 33x equals 198. Divide both sides by negative 33 to get x by itself. And x equals what? Negative 6. Negative 6. Okay. How do you want to solve for y? Not done yet. Tristan, top equation? Very well. So I'm going to put it kind of down here, I think. Give us some more room to work a little bit. So we've got negative 5x plus 12 times, whoops, we solved for x, didn't we? Hold on. Negative 5 times negative 6, there we go. Make sure you plug it in for the right variable, otherwise you did all that work for nothing. Negative 5 times negative 6 plus 12y equals 90. This equals 30. So 30 plus 12y equals 90. That gives us a two-step equation to solve. Subtract 30, divide by 12, and we get y to be 5. Okay? Questions on that one? All right. On to the third one. And we have a couple people ask about this, so it must be kind of tricky. But we'll take a look-see here. In this case, we have options. If we want to get x, to eliminate x and get those coefficients to match, what would we go to? 20. Least common multiple of 4 and 10 is 20. What would we go to if we want to get the y coefficients the same? 12. Okay. Does it matter? It doesn't. So we'll do this. Raise your hand if you would like to go to 20 and get the x coefficients the same.
Yeah, come on, people. Raise your hand.
Raise your hand if you'd like to get the y coefficients the same. The y's are victorious. So we are going to multiply our top equation by 3, and we're going to multiply our bottom equation by 4. Okay? So 4x times 3 is 12x. Negative 4 times 3 is a negative 12y. And negative 20 times 3 is a negative 60. Just distribute that 3 into every term into the parentheses. Now, multiply the bottom equation by 4. Negative 10 times 4 is a negative 40x. 3y times 4 is a positive 12y. And negative 20 times 4 is a negative 80. Right? Now, how do we get a negative 12 and a positive 12 to be 0? You're going to add them, right? We're not going to subtract here because negative 12 minus 12 would be negative 24. That doesn't get to 0. Okay? So in this case, it's the first time that we've had to do this. In this case, we are adding these equations because negative 12 plus 12 is what brings us to 0. Yes?
Would it be okay if we multiplied the top equation by negative 3?
Yes. If you want to get in the groove of always subtracting so you don't have to think about this, then you just have to make your signs the same. Both positive. Even if they're both negative, you're still going to subtract to get them to be 0. So what she's asking is, can you multiply that top equation by a negative 3 to make this positive 12y here? Of course, change the sign of everything else. But yes, you could. If you multiply the bottom equation by a negative 4 to make this negative 12y here, you'd still subtract. Okay? So kind of the rule of thumb is if the signs of the coefficient are the same, subtract. If they're different, then you add. But in this case, we are going to add. So 12 plus negative 40 is what? Negative 28. Negative 12 plus 12. Oi! And negative 60 plus negative 80. No. Negative 60 plus negative 80.
Is it 120? Negative 120.
We'll get there. Negative 140. Negative 140. Okay. So, because 0y is just 0, we've got negative 28x equals negative 140. Divide both sides by negative 28 to get x by itself, and what do we get? X equals 5. Okay. Now we go back to one of the equations. Doesn't matter which one. We can use any of these 4. Okay. We'll just use the top one because numbers are a little bit smaller there. But if x is 5, I'm going to put this all the way down here now. Then 4 times 5 minus 4y equals a negative 20. Or 20 minus 4y equals a negative 20. Subtract 20 from both sides. That gives you negative 4y equals a negative 40. Divide both sides by negative 4. Negative 40 divided by negative 4. Y equals 10. Okay? In the spirit of Christmas. Red and green. You will.
No.
Yes, you will.
I already have to stay after.
Questions on this so far? All right, let's see what the second page has to offer here.
We do easiest one first.
Well, they're all kind of
No.
Pick any of the 9. I have my guess as to which one you're going to choose, but we'll see. Briggs? The decimal one. Yeah, the decimal one.
Did you guess that one?
Yes, that was my assumption.
Hey.
All right, 1.25x plus 4.5y equals 105. 3.75x plus 1.25y equals 70. We are going to solve this using decimals because we're going to flex. But if you don't like decimals and don't want to deal with them, what could you do to eliminate the decimals before you start and then not have to worry about them? Paisley? You could go fraction form, but I'm even more scared of fractions than I am of decimals. I mean, at least decimals have a point. What could you do? Multiply them all by 4 would do it. Why is that?
Because 4 would make them all.
4 would make them all into whole numbers. Or
4 would make.
you can also multiply by what? Since they're all out to at least the
16, 32.
since they're all out to at least the hundredths place, if you multiply by 100, you're just going to kick each decimal over 2 spots. It makes for some very large numbers, but that would do it as well. Okay, but we're going to stick with the decimals. What do you want to multiply? What do you see here? What can we do? Cole.
No, never mind.
How do you make a 1.25 and a 3.75? What's the least common multiple of 4.5 and 1.25?
100.
You could do that if you wanted to eliminate the decimal. We aren't going to because we are mathers.
Multiply by 100, you would have to multiply all of
Everything, which makes for some very large numbers. Yeah. Let's ignore the decimal for just a second. 125 and 375.
Oh, they go together.
What do you have to multiply by? 3. Okay? Same thing with 1.25 and 3.75, right? We multiply everything by 3, it's going to get those x coefficients to match up. Right? So 1.25 times 3 is 3.75. 4.5 times 3 is 13.5. And 105 times 3 is 315. Okay? The bottom equation, we don't have to touch because we already have our matching coefficient for x. So 3.75x plus 1.25y equals 70. And now what are we going to be doing here? What operation is going to make a positive 3.75 cancel out with a positive 3.75?
Subtraction.
Subtraction. The signs are the same, so we're going to be subtracting. 3.75 minus 3.75 is 0. We've got our ox. 13.5 minus 1.25. $13.50 minus $1.25. Good. 12.25y and 315 minus 70. 245. Because we've got 0x, we've now canceled that out. We've eliminated it. So this is just the same as 12.25y equals 245. What does y equal? 20? It works out that nicely.
No,
Gotta love that. Do we have a second on that?
no.
What'd you get, Cole?
I didn't do it.
Well, then why are you?
Talking.
20? Good? Okay. Y equals 20. Now that we know what y is, we can go back and solve for x. Does not matter which equation you plug it into, but we'll go with the top one. So we have 1.25x plus 4.5 times 20 equals 105, which gives us 1.25x. 4.5 times 20 is 90, equals 105. Subtract 90 from both sides. 1.25x equals 15. And what is 15 divided by 1.25? 12. X equals 12.
Oh god.
So now that you've seen a couple more of them,
This makes sense.
I'm a fan of elimination, just because you don't have to worry about slope intercept form, having a coordinate plane. Substitution can get messy when you've got decimals and things to work with. You have to convert it to slope intercept form or get one of the variables by itself. Most people, in the end, I shouldn't lump you together, but most people go with this one for their final systems of equations choice. But everyone's brain is a little bit different. So if you like one of the other methods better, all three will work. That's the beauty of it. All three will work. Finn.
I have a joke.
Okay. I got my rim shot ready.
Okay. What would Santa say if he was a pirate?
What?
Oh.
Yo ho ho ho.
Bum, bum, bum.
Oh, that was the wrong one.
That's the one.
There it is.
Yeah.
No, I added that one because the pre-upper class, they are like super silent. Like they don't say anything ever. And so now I.
Yeah.
Yeah, no, they are. Just zip the lip. We've got time for one more together. Which one would you like to do? Chase. The last one?
I'm the last one. It's so iconic.
So, 3, 2, 1, you are Wyatt. Okay. What step do we need to do first before we can start working to get our like coefficients with the last one? What's different about it than we haven't seen up until this point? Chase?
Oh, there's two on one side.
Yeah. Notice how the first one is in standard form, or at least have both y and x on the same side. The bottom one, y and x are on opposite sides. We can't start to add or subtract the equations until we get them on the same side together. Okay? So, what are we going to do?
Did I say the answer?
No. What are we going to do first here?
I'll text you. Oh,
Katie.
move the X over.
Move our negative 9x over to the other side. So that x and y are on the same side. And just like any other time, we move a term,
Has to flip the side.
We split this.
it becomes positive now, right?
Do it.
So our top equation is 2y minus 9x equals 7. Our bottom equation is 2y plus 9x equals negative 11. Don't lose those signs. That negative sign in front of the 11 follows it down. The negative 9x, when you move it to the other side, becomes positive. Okay? And this is the system that you are solving. And we have got options here, people. Can we do both? What could we do?
We could multiply.
Raise your hand. What could we do? Cole.
Subtract or add.
We could subtract or add. If we want to cancel out the y coefficient and get oi, we would subtract. If we want to cancel out the x coefficient, we would add, right? Because 2y minus 2y gives us oi, negative 9 plus 9 gives us ox. It all depends on which way you want to go.
I like
Oi,
better.
oi,
Like,
oi,
because it's
oi,
an actual
oi, oi,
word.
Fine. So 2y minus 2y is oi, that's 0y. Negative 9x minus 9x is what? Negative 18x. Pay attention to signs. Watch out for that. And then 7 minus negative 11 is positive 18. Okay? 7 minus negative 11 is a positive 18. I think you can take it from here. The last step here? What are you thinking, Izzy?
I don't know. That's why I need help. Sometimes people
What will it be?
know, but-
Divide both sides by negative 18. And x equals negative 1. Okay? Go back to either equation up top. Plug in negative 1 in for x. We'll go over the first one. Actually, we'll go to the bottom one because that has x kind of by itself, sort of on the other side. So we get 2y equals -9 times -1 minus 11, or 2y equals 9 minus 11. You're the one who wanted me to keep going with this here. Pay attention. 2y equals -2, and y equals -1 as well. Nick.
What's your personal opinion? What's your personal favorite on either ox or oi?
They're both fun.
No, what's your personal?
I don't have one.
Pick one.
I can't. I can't.
Pick one.
Pick one. Wait,
Goal.
We use it if let's say we get the number 2 times. Right? We use it for extra recess.
Nope. All right, homework is the rest of PO42 part 1. The other 7 questions on this page due tomorrow. That's how you math.
Don't forget to like